Cool. I'll tell you one interesting thing. Doing a topic on Terraform when in prior years it wasn't such a really big topic to now hear it being mentioned almost every session or every other session. So it's kind of awesome. So I'm going to do a crawl, walk, run. It's not particularly tech heavy, but it's more interested into what you would expect when you journey from first looking at it from a technology and a process and into growing it beyond and into your teams, and then eventually growing it at scale when it's not just your teams or your neighbors actually running through it. So, I'm Brian. I've been doing Terraform since, .3. It was really interesting back then. State files were definitely collateral damage back in those times. But things are much, much better these days. So I've contributed to the project. I contribute to a lot of other open source projects. I craft brew in my spare time. If you happen to find yourself in the San Francisco area and you want to contact me, by all means, I'll show you around. So I work for Anaplan. Anaplan, as plan states, it's a planning company. I'm always looking for people for my team in particular because we have interesting cloud challenges as we move around. So if you're interested, come check out our jobs. You could, of course, find me on Twitter and say, hey, what's open and what's up? And we do have a number of offices around the world, and we do have a little bit of remote work. So we can always use your help. So about infrastructure as code. Well, I mean, you don't just deploy your infrastructure. It takes a lot of loving care. So when you start embarking on this journey, usually you've got a lot of manual rote process, your ServiceNow tickets, your people either creating VMs in the early start to where now you're moving into APIs and you want some consolidation. This is where Terraform comes in. Then you move on further. So this is going to be our journey. So beginning with crawling, you're going to start looking at the very beginning of this. So let's look at what its structure is. Terraform or TF read files, that's your HCL, that's where your code comes in. Your TF vars, usually they're going to be kind of some sensitive information, the default populations that you as your own workstation want to be able to supply. Your API credentials to AWS, your credentials JSON to Google, your Azure key, things like that, just to name a couple of the first starters. You don't want this committed most oftentimes, but then again, you're going to have a problem when you start moving to other teams. They need credentials, but they need to add their files. So we'll get into that. Terraform is a state engine. You need that state. It's very, very important. You don't want that committed. That's going to contain those sensitive things that we just referred to. And of course, if you have plugins, any kind of context or your information, that's going to be in your local .terraform directory. So if you look at a number of repos online, you'll see in your git ignore as it's committed, you'll exclude things like tfstate.terraform and some other, often CI-related files. So your phases, you're going to go in init. That's going to download your plugins, do a cursory syntax check. Plan is going to tell you what it thinks it's going to do. Apply is going to actually try and make it so. Well, it doesn't always succeed. You can try and apply and apply and apply again. And then, of course, my most favorite phase is destroy. I believe in a life cycle of things, especially a cattle not pets sort of mentality, in that I want a final state of things. I want it gone. And so in a lot of the processes that we exercise, we want an environment to hopefully exist for as little time as possible. And that includes the full life cycle. We don't want it lingering and languishing and growing to the point where it becomes so uber critical that a team needs it. I don't want that. I want you to be able to move on. Some of the most favorite things, format for free will basically do a good job at linting your code, aligning it, making it a whole lot more readable. The HCL syntax is great for that. Refresh allows you to cover all those wonderful points at which somebody went into the console and changed information on you. But you need to acquire that. You don't want to fail when you decide to run any of your code or automation. Console is where I spend probably a good 20% of my development time. I'm testing interpolation. I'm figuring out what math can I use, or what information can I reuse from what I've already gotten. How can I prompt the user that when we're creating things, give me more information necessarily that I need, and then I can cover a multitude of places by parsing strings, filtering lists, doing things like that. And so in console, you can test that. And of course, state. We move state, we inspect state, we take a look at all sorts of things. Instead of telling people, hey, run the plan again so you can see the outputs, no, just Terraform state show, the resource name. You could get a whole set of information about it. Cool. So let's do something simple. Hey, let's look at Google, create a network. This is so uber simple, right? You can go into a UI. Well, logging in is at least 2 clicks if you have 2FA, maybe 3. You have to then pull your phone out of your pocket, click the confirm, or grab the code, input that into the UI. Now you're just in your project. Now you go to your project, you're gonna go into the network tab, you're gonna do add a network, you're gonna name it. Now you're finally done. 2.5 minutes later, well, I have 12 lines that just does that. Just run it. Also, when that person no longer needs that, again, my favorite command, Terraform destroy. So then you can just clean that thing up. But of course, when you're crawling with Terraform, this is probably what it's going to look like. You're going to start with a small amount of sets or items. Choose something small unit that traditionally is a repeat or rote practice. Creating things that may live a little bit longer than normal, networks in Google, VPCs on AWS. You have a litany of options of things that traditionally will stay around. So I suggest starting with those. Make some small time savings for yourself. Get rid of the really rote tasks to just be comfortable with the language and inspect the providers, see what you can get away with. So now let's go to walking. You have maybe some variables. You're supplying some information. But now what's more important is that this code is going to live and maybe not necessarily be quite as modified. So I'm going to give a lot of people some options. Great, grab my code. If you have credentials to the environment, that means we allow you to create stuff. Update your information. Otherwise, you're just simply going to get the default stuff. Now, mind you, if you're collaborating with somebody else and some of this has already been done, you're probably going to get conflicts. But needless to say, this is at least telling, not just me, but other members of my team. When you get this request and I'm on vacation, you can pull this code, add your credentials, and create some networks. And this will save our time. So now, going back into Terraform console and talking about interpolation, you can kind of see down in the provider, we're doing some interpolations. We're joining on hyphen. We're slicing and splitting off of hyphen from our var zone. So one of the nice things about this is with zones and regions, well, zone is only a component of the region. So if we drop that hyphen A, we now have our region. That's what the provider wants, but what something else might want is it might want the more specific information like zone. So we'll provide that as an item, but we're going to chop it up. So we're going to take that item, we're going to make it a list out of the hyphens for 3 elements. In split, we're going to do 0 to 2, 0 inclusive, 2 exclusive. We do not want the last element, so we'll drop it. But in order to provide region, region is a string, so we have to join that back up with hyphens again. So we got a list, we're going to join that hyphen, we're going to re-put that US hyphen west 1 and keep that going. So this is a little bit more portable. You can take your team's PRs and indexes off of it. Some other interesting options. If you are providing defaults, you won't prompt your user for them. If you want to force them to give you that information, say in the networks, we're no longer going to create Terraform network for every one user who pulls this stuff. We'll just simply delete the default. Now on the CLI, this will prompt you. It's like, hey, give me a list. I want to know what is the networks you want me to create. But anymore these days, we want to give them at least an easy ability and an expectation of success. So again, this code is reusable. We could start to do things like introduce CI/CD. We can get PRs and feedback. So we have that expectation of getting a loop. And then, as I pointed out, we already know the zone, therefore we already know the region because, well, that zone's not going to be outside the region. So we can reuse this information through crafting interpolation on Terraform. Make efficient use of our time and also get, something better out of it. Now you're going to start coming into problems. Not just you are running the code, somebody else is. And so somebody else's credentials might accidentally get committed. We hope that never happens. If you're using the same file types and you're excluding the right files, this won't be a problem. We've definitely committed credentials every now and then. We solve that by destroying a repo and then recommitting it. We depend on local files still. We're only walking right at the moment, so we're probably still running this from our own machine. CI is probably an interesting thing. We might want to look at it. However, this introduces, what do we do with that state file? Because if in our CI engine, if we keep the CI up and the state file is there, well, that's a security problem. It has to be incorporated in where our sensitive information is. But if we externalize that state, we have to make sure that that's secured properly, that only the right people have access to that state. Naturally, though, you have to read the state in order to run the plan, so you can't just willy-nilly give it to a developer, because if they decide to get inquisitive, they can take a look at the state because their credentials need it in order to update. I've definitely been guilty of boiling the ocean. We've had some interesting run times where I've had Terraform plans running in excess of over 30 minutes, successfully, might I add, but across thousands of lines of code. This is not a really good way to do things, because you think, it's like, great, well, I'll just deploy an environment. Well, what does an environment consist? My 45 apps, my 16 load balancers, a couple of S3 buckets, 2 databases, the list goes on. Well, that's just one plan, right? No. So as you begin getting towards, say, from walk to trot and starting to approach to run, units of scale become an issue. And so then your blast radius becomes a concern. Terraform does actually a pretty decent job just by default keeping your order of operations. However, sometimes you need a depends on mechanism in order to make sure that that last resource did run. And so I implore you, look at all of these syntax options and items that you can make use of. Now, if you notice, one thing that I don't necessarily cover here is modules. Now, that's kind of important. When walking with Terraform, I really recommend that you actually know what's going on underneath, maybe not somebody else's opinionated view of the resources and inputs. Experiment with modules and play with them, but you need to know what goes on underneath. Some of the most fantastic discoveries that I've made in terms of code that I can reuse is by going into a module and seeing what somebody else has done, especially with interpolation and crafty natures like that. But understanding really down at the base root levels as to what is it doing that somebody else said it needed to do in X order, that's actually really meaningful. And so while I do encourage the exploration of modules even within and amongst our teams, like, why don't you use the AWS VPC module? Well, I don't need to give 14 inputs. I only need to give 3. It's much simpler, and I don't need to have another thing download just to run my VPC. So, units of scale and blast radius. At the very end of walking and trotting, I really want to suggest that you start looking at testing. There are various opinions on infrastructure as code testing. Like most developers, I'm in the camp of you need to test and verify your code. These are the two that I, myself, recommend. If you love Go, TerraTest is going to be your tool, It's wonderful, it's beautiful. You can get actually fairly deep into your state and your intention. If you're more familiar with things like RSpec and Kitchen as a CI framework, Kitchen Terraform has been doing this for quite a while. They have a very good product. What I do implore you is choose one and try to stick with it as much as possible. I can make a suggestion in that TerraTest is probably way more appropriate for developing your own internal modules, and Kitchen Terraform is more appropriate necessarily for testing your plan, what you plan to actually do, the infrastructure that you really would like to create. And of course, as always, it destroys. I love destroying. So now our repo structure comes into to question. How do we want to organize this code? So Hashi has these suggestions or recommendations actually up on their site when you're loading and onboarding into Terraform. Multiple workspaces per repo, it's fantastic. I use one code base, I supply the variables, dev, stage, prod, they all look the same except for what we put into it. Regions are variables, quantities, counts are variables, the actual S3 buckets are all inputs and variables. These are all actually committed as code, and we'll import those variables so as they're committed and changed. Those environments, when that workspace hits, gets that information. If you have your CI integrated, when you make that PR or change, you can run plan against everything that uses this plan. And then you could see directly in your CIs, like, hey, I expect prod to have no change. I expect stage to have 2 changes. I expect dev to have no changes because we've already done it and we're promoting it to stage. So you can actually integrate that. Branches end up resulting ultimately in a little bit less code, but you have longer lived branches. Anybody familiar with Git flow? Probably this would be your framework. A little bit more customizable, and also there's kind of a real direct promotion. However, you start fighting drift, and I'm sure that nobody wants to do a cherry pick merge. Directories, they're very explicit. You say, this is what prod's framework is, because prod may have, say, an Elasticsearch cluster that spans much greater of an area than, say, the one single instance Elasticsearch cluster in one zone. And so those differences sometimes cannot be covered with variables. So you have lots of options. Naturally, there are a few others. For repeatability, my personal preference is to try and reuse the same code as much as possible, and then question why would one environment be different than another that would necessitate me changing my model. So now we really want to get into running with Terraform. Now, running is not so much about the code as it really is about the people that you're interacting with, the teams that you're growing it to. Because you don't run alone, especially in a company of any size. And so you yourself cannot do the work, and you can't automate every facet of it. We all love to and try. I'm always constantly looking to automate myself into my next position so that I no longer have to do what I've discovered is now remedial stuff. So now we want to go from my team, my group, or maybe even my neighbor to teams spanning geographies. I don't necessarily want to know when you want to create a Google network. Just do it. Collaboration becomes critical in that if we're going to change a paradigm, we need to communicate. We don't always do that through code. We do that oftentimes offline. But when we submit the PRs to the code that's constantly reused around teams in the world, we communicate those changes to them and say, hey, I have this PR up and running, and of the 9 workspaces that use my network code, 4 of you are going to be adversely affected. We need to make this change. Please tell me how. Governance becomes super important. The transports of those security keys, the sensitive information in pieces. So things like your CI engine and secrets engine, implementing Vault, doing Terraform Enterprise, Circle CI, GitLab, etc. That becomes the place where your policy has to be crafted, ruled, modeled, and enforced. As I mentioned, running Terraform from someplace other than your own personal machine, because you may not have personal access to it. Potentially, you're in a high compliance mode, and we only allow these changes to happen from the corporate office. Test-driven development. We want to validate before we commit. I want to see what the CI, I want to see what the testing does, I want to see what TerraTest outputs. I want to assert my changes and make sure that across all the workspaces that I'm going to go. And then when I commit that change, I can then see Sentinel provide me that information that, hey, policy says you can't do $4,000 in infrastructure, or things like that. And then, the feedback needs to be immediate, because if multiple teams are going to be using your plans, your modules, or any kind of that sort of information, you need to make sure that you have that rapid feedback loop. So what does running look like? Well, it's actually quite large. You want to build, especially against your VCS, you want to send that to your workspace, make sure that your workspaces are, receiving that change. We implement this through Terraform so that we get that full life cycle. Terraform is responsible for telling me what provider, with the inputs to what region, what zone, geography, et cetera. And so we do this more than with just one cloud. And we execute this with more than one geographically distributed team. As I mentioned, we do development both in the UK and the US, in a couple of different sites. So when I have a couple of teams in the UK time zone trying to deploy stuff, I don't necessarily need to be bothered. So we've kind of covered the full gambit. And of course, as mentioning, crawling, you want to investigate it, take a look at your units of scale and look at things as you walk. And then as you run, it's more about who you're collaborating with and how you're collaborating with them, making sure that your feedback loop comes in and that you have the appropriate guardrails that don't get in the way of other people. Cool. So again, I'm Brian. If you want to find me, at MengusB, it's my Twitter. You can contact me pretty much any which way. Thank you.